In scientific imagination, oxygen has shown for decades as a biological beacon. Its abundance on Earth is intimately linked to life, as forests, oceans, and microorganisms have woven an atmosphere where this gas dominates the air we breathe. If you like this content, do not forget to subscribe and give like. Your support is fundamental to continue sharing fascinating information about the universe and life on other planets. When astronomers observe distant worlds, finding oxygen is an indication of possible revelations about extraterrestrial life. However, the cosmos is complex and rarely offers simple answers. A new study led by Margaret Turcotte-Seavey investigates how to distinguish between a biological atmosphere and one that only seems alive. This research reveals that a small amount of water vapor can alter the reading of oxygen on a rocky planet. M dwarfs, the most common stars in the galaxy, are especially favorable for detecting exoplanets. This makes their worlds priority candidates for telescopes such as the Habitable Worlds Observatory. The research is based on a classic study that showed that the photolysis of CO2 can generate oxygen and ozone abiotically. This means that a dead planet could look like a Eden. The chemical mechanism behind this phenomenon is disturbing for astrobiology. Ultraviolet radiation breaks CO2, generating free oxygen in very dry conditions, which could be confused with biological activity. Turcotte-Seavey's new work uses a model to simulate a planet with CO2 atmosphere and different levels of water vapor. Results show that by introducing water, oxygen buildup drastically decreases. The presence of water not only accompanies habitability, but also cleanses the chemical scene, making it difficult for an abiotic atmosphere to imitate a biological one. This makes the coexistence of water and oxygen a sign of greater interest. The quest for extraterrestrial life is evolving into a more mature phase. Now it is crucial to understand how gases interact in a spectrum, the evolutionary history of the planet, and other environmental factors. The Habitable Worlds Observatory is tasked with identifying potentially habitable worlds by analyzing gases such as oxygen and methane in their atmospheric context. Studies such as Turcotte-Seavey's are preventive and teach about possible errors in interpretation. The beauty of this research lies in the fact that searching for life involves not only finding signs, but also learning to distrust the mirages of the universe. Oxygen is a formidable clue, but it needs to be analyzed in conjunction with other elements.